All right, so once again, tomorrow, your test is on Thursday, Friday, right? For you guys, Friday. Use that time to do the review and the more practice. Get that extra practice. You skip out on that, it's only going to hurt you, I think. But we're going to be working on math team problems. Now, these are just problems that used to show up as ciphering questions, written test questions, or the same kind of idea. They're not multiple choice here, so I've dropped that part off. But anyway, if they did come for the written test. But these are examples, yeah. What is it on yours? 95. So page 95, and we're just gonna, and also I really want to caution you on the test. Do y'all know the difference between solve, factor, simplify? Solve, what am I looking for? X values or whatever the variable is. I want answers. Factor?
You factor out.
You're factoring, right? Do you, if it says factor, do you factor and solve? No, and it probably won't be an equation. Like, I could have, this is going to be a solve. There's an equation, solve, there's an equation. There's no equation here, right? So even if, or even something like this, even if it was something like that was factorable and solvable, if it just says factor, only factor. And then what does simplify mean to you? PEMDAS. Make sure you remember that. Simplify means PEMDAS. Don't try to do anything less or anything more. Part of this test is, do you understand those directions? And it may, I think if I remember correctly, it was a couple weeks ago I made this test. It seems like I tried to put most of the simplifying stuff and the solving stuff and the factoring stuff together, so you can kind of think, you know, categorically like that. But I'm not 100% sure. It might be mixed up a little bit, depending on which version you happen to have. So first thing, solve. Now when you look at that, this right here, you might go, what in the heck is this? Okay? This is what you should be thinking when you see this. Because it's something equals something times something, and you probably, if you know your powers from your powers quiz, recognize that all three of these numbers could be written as a what?
Power
A 3 to the something. This 27 is a 3 cubed, that is a 3 to the 4th, and that is a 3 to the 6th. Okay? And if you know that, you're in great shape for a powers quiz, or maybe at least with your 3s. But if that's the case, if this can be written as 3 to the something, and that could be rewritten as 3 to the something, and this can be rewritten as 3 to the something, could you multiply these like bases together? And then if you did that, you'd have 3 to the something equals 3 to the something. And I'm guessing at this point, you could say, well, if the bases are the same, the exponents must be the same. And you could solve the equation. Now you need to be able to see that when you see something like this. Okay, so let's take a look. How can I rewrite this so that it's a base of 3?
3 to the 6th, parentheses, n plus 1.
So 3 to the 6th, parentheses, n plus 1. And how can I write 81?
3 to the 4th, parentheses, 2n. 3 to the 3rd, parentheses, n.
So 3 to the 3rd, parentheses, n. Now, what is our rule for multiplying? I mean, for when you have a power raised to another power? What is the rule? Power to a power? Multiply those powers. So what do I end up getting here on the left when you multiply? 3 to the 6, sorry. 3 to the 6n plus 6, good. And then here, 3 to the 8n, and then times 3 to the 3n. So I'm getting closer. And then now, by the way, don't do this now. Like bases, what does it tell you?
Add.
What else does it tell you? Keep the base, multiply the bases? Keep the base. Every year I have somebody who writes 9 and then adds those. I know that you learned when you were a kid 3 times 3 is 9, but do you know why 3 times 3 is 9? Because you kept the base and you added the exponents. All right? You can't teach that to when did you learn how to multiply? First grade or something like that? But so, like bases, you have, like bases, you have different powers. You have to keep the base, add the exponents. Keep the base over here. And look, now that I get it down to one base on either side, this property called the one-to-one property is in place, I can now just basically ignore the 3's. Because if the 3's are the same, then the powers must be equal. So you just solve 6n plus 6 equals 11n. You get 5n equals 6, or n is 6/5. Not too bad. Can anybody guess what the number one error is on a problem like this? Right here, they cancel the 3's out. And then guess what they end up doing right here? They end up multiplying because that's multiplication. But the reality is, if I cancel this and multiply, I'm going to get 24n squared, right?
Mm-hmm.
But what I wanted to do was get it to where you had the one-to-one property in place. 1 3 on one side, 1 3 on the other side, and then it's obvious. This looks like this if the two top parts are equal. Y'all seeing that? Great math team question, shows up all the time. Of course, they'll make it even uglier. They'll do things like, instead of 27 to the n, they'll do stuff like 1 over 27 to the n. And what would you have to do to change that to a base 3? The 27 is like a 3 cubed in the bottom, which would make it a what? Careful. What's a 3 cubed down low if you bring it up? A 3 to the negative 3. Y'all remember that? An exponent that's on the bottom, if you bring it to the numerator, it becomes a positive. I mean, it changes the sign. So that would be like a 3 to the negative 3 to the end. So they'll do things like that to make it even worse, but anyway. All right, moving on. What about this? It says solve. I can tell you a lot of times the first thing I see people do is, well, that's pretty ugly, so I'm just going to start foiling this out. And then they get something that's x to the 4th, and sometimes you end up with like x to the 4th, x to the 3rd, x squared, x to the 1st, constant, and they end up with this 5-term polynomial. Do you know how to factor a 5-term polynomial? Yeah, I don't either on that. I mean, I have a process to solve it, but it's not really factored. But what do you notice about this? Does anybody have any ideas on this? I could distribute that in, again, and I could FOIL all that out and then see if it refactors. There's a special thing about this. What do you notice? That's the same? Now, I have a question. What if I just made a little substitution? Like, if I'm absent one day, a substitute comes in there and holds my place until I come back, right? So what if I said, you know what? Just for now, I'm going to let this x squared plus 1 equal a. Pick a variable that's not the x. I'm going to let it equal a, and I'm going to put an a in its place. A squared minus 9a plus 8. Now, does that look like it might be a little easier to solve? Now, I can't leave the a in there forever because I didn't want to know a. I want to know x. But man, it sure does factor nicely. A minus 8, a minus 1, a equals 8, a equals 1. And like any good substitute, it leaves and lets the original value come back. So I'm now going to take the x squared plus 1 and plug it back in there. Now I can solve. And do you remember what to do if you get x squared equals 7? You're going to square root both sides, and you get x equals, and yeah, you get plus or minus the square root of that 7. And then over here, you don't really have that problem because you get x squared equals 0. So you get x equals, you can say plus or minus 0, but it just gives 0. You with me? All right. What about number 3? Factor. Now it is a 4-term polynomial, right? I didn't in my video yesterday, I wrote a big list of, I think I might have done that with you guys also, but I put a big list in one of the videos of maybe a strategy, and at the bottom of those strategies, it was like factor 4-term polynomials. And you got 2 options. Grouping them in pairs or 3 and then 1. And then I said, you know what, check the 3 and 1 first. It doesn't happen as often, but to have a 3 and 1, what has to occur? You're going to have 3 perfect squares in there. And I see a perfect square here, 3x, 3x. Perfect square there, if you ignore the negative, 4y, 4y. And a perfect square there that's 5z, 5z. So I think that the 3 and 1 might be in play. And then we said the next check you got to make is the number that's not a perfect square could it be a middle term? Because it would have to be the middle part of the trinomial. Now, if it's got a y and a z with it, then it would have to go with what? If it was a trinomial, it would have to go with the y and the z term. So I'm going to group all of this together and put a plus right here. Now I know people that don't do it this way, but that's what I do. I group everything with its signs, drop a plus. Now, if you remember this process, what has to happen here? This trinomial has to end up being a what? A perfect square trinomial. And this is already a perfect square, so that I can have a perfect square minus a perfect square. Now to have a minus there, what am I going to have to do? Factor a negative out, so let me do that. I factor a negative out. Right there, I end up with positive 16y squared, negative 40yz, positive 25z squared. Now, is that a perfect square trinomial? Because that's the last check, and then you start with the process. Positive on the front, positive on the back, and if I do the check, 4y, 5z, if I multiply those and double it, do I get the middle term? Then all I have to do is take that 4y and the 5z, put the sign of the middle in there, and square it, and that's how it factors. And then I just drop everything else down. And every year I have somebody who's done right there, and they're like, yeah, factored. But is it factored? Factored means it's nothing but multiplication, and you've got something minus something here. But now I've got a difference of squares. Now all that process was to rewrite this as a difference of two squares, and once I do that, what do?
4y minus 5z plus 3x, 4y minus 5z minus 3x.
You gotta be careful, because the 4y minus 5z is at the end, right?
Could you not have, so like in the beginning, like in that first part, can you not factor a negative out of the whole thing? Like,
Whoa, right here?
yeah.
If I factor a negative out of the whole thing, then it would have these things flip-flop.
Oh,
but
it's
you
not,
would,
and then
but you would still have to remember that negative all the way down.
I got you.
And you could do that, that technically would be factored, and then it would be exactly what you just said.
Okay.
But if you don't do that, which I didn't do, then make sure the 3x
So then the 3x is in front, so it's 3x.
plus 3x minus, and then when you split this up, here it won't matter that you don't have parentheses around it because there's a plus. So you could go ahead and put 4y minus 5z because the plus isn't going to change the signs. But here, what would be wrong if I write this the way I'm writing it right now? If I write 4y minus 5z, I have now forgotten to distribute the negative in. Are you with me?
Yeah.
It's really all of that being subtracted. So what ends up happening? Negative 4y plus 5z. So you would have to have that sign changed in the end. If you want to take another step to do that, you can. Does that make sense?
Yeah, well, okay, so if you did.
But if I had taken a negative out at the beginning, which
Yeah.
I'm not saying I'd encourage that, but if I did,
So you, okay, never mind, yeah, it's fine.
then this would already be
That would be a negative.
this would be a negative 9. Like this, it would look like this if you took a negative out. You'd have a negative 9, positive, negative, positive, and then you could say, I'm going to put that negative 9 squared at the end,
Yeah.
at negative 9x squared. And remember, this is already positive, negative, positive. And then I'd have this right here as a difference of two squares. And when you were finished with all this, it would look like this would factor as a, again, I'm not encouraging this, but just to answer your question, that factors like this. But remember, there's still a negative 1 out there, and you would have this negative 1, and then you would have 4y minus 5z plus 3x, 4y minus 5z minus 3x.
So that's what my question is. If you were to multiply that negative 1 in, it'd make both the phi z's positive, but in the bottom one,
No, there's only one negative one. There's not one for each of these,
okay.
right?
Okay.
So you'll look at this one right here, 4y,
Okay,
look at this,
I see.
4y minus 5z minus 3x.
No, I see what you're saying, because
Look,
it
here
would
you
have
go.
only been like, it would have only been the first term.
See how this matches
Yeah.
this one perfectly? So that matches that one, and if I multiply negative in there, I get
Okay.
negative 4y, positive 5z, positive 3. But that negative one would only go into both. I mean, only go into one of those factors.
Yeah.
And it wouldn't matter which one.
Okay.
So I wouldn't recommend that, but you could totally do that if you see that the binomial is gonna be at the end and you don't like that.
Yeah, that was what I was seeing first, and 'cause
Yeah.
the negatives always.
No, I hear you. No, there's more than one way to skin a cat, right? What about 4? I never heard that. This new physics this new physics teacher we have, his dad used to teach physics here, and he hated cats. So anytime he did like a projectile motion problem, he was always shooting a cat out of a cannon. And there were some teachers in the building who like loved cats, who had like cat pictures everywhere. And anytime he would do that, and he would say, you know, the cannon shot Miss Ham's cat 400 yards, blah, blah, blah. But one time, have you ever seen that? It's like some little meme where it said, sadly, a dead cat on the side of the road, and some guy had hammered a sign in it and said, free cat. Anyway, I thought it was pretty funny, but he took that and sent it to Miss Ham's.
And
But
it's still
anyway.
here.
No. She kind of just decided to go full circle. She taught AP English, and one day she just said, I'm out. And now she has a little farm. Like a little fresh eggs to table, like fresh food to table kind.
Very interesting.
She's like, yeah, she went from being like all sophisticated to literally out there on a farm, which, you know, kind of cool actually. Totally changed the pace. What about this? Another 4-term polynomial? It's worth a quick check. Is it a 3 and 1? Nope. Perfect square, yeah, because that's 2x squared, 2x squared. No. So your best bet on this is grouping in pairs, right? So I just do that check real quickly, and then I always say, well, why don't we just try the first two and the last two? And if you remember what I did, I grouped them, but I got to put a plus in there. So when I first group them, when I go to factor, I look at this and I go, well, there's nothing that factors out of that. Well, that's kind of a red flag initially, but I go, all right, I'm just going to roll with it for now. And then when I look at this one, all I can do is factor maybe a negative x, and that would give me this. And do those match? Then this was not the way to group them. But I didn't know that until I first looked, right? Or maybe if you looked ahead without grouping them and said, wait a minute, this is not going to work well. If that doesn't work, then just do this. It's a nice, easy way to do it. Rather than trying to think about what would be grouped, do this. Just switch the two middle terms. And that would give me 4x to the 4 minus 12x cubed y plus 15y minus 5x, and then just group them again. And if they don't work this time when you group, then it's prime. Y'all with me? But now you'll see, oh look, a 4 comes out, an x cubed comes out, and I'm left with an x minus a 3y. And then over here, now I'm going to accidentally, well not accidentally, but I'm going to take out what pops into my head first, which is a 5, just to show you what would happen. And I end up with a 3y minus a 1. No, minus an x. Now, do I see the same thing here and here? No, positive x, negative 3y is not the same thing as positive 3y, negative x. So what would you need to do? Take out an extra negative or put a negative back in if you already did. If I take a negative out, now it's negative 3y plus x. That is the same thing, even though the order is different, right? And at that point, I can factor out the x minus 3y, and I'm left with a 4x cubed minus 5. And let me caution you, multiple times over the years, when you're done factoring, the factor that you have left can be factored further. Like what if this ended up right here being 4x squared minus 9? What would that be if it was 4x squared minus 9? difference of two squares. So you're not done factoring then. So always take a look at your final factor and see if you could take it down a little bit further. But in this case, I'm finished. What about, I want to jump around a little bit because we have a shortened period today. What if I jump to number 8? This is from yesterday, right? And this is a math team level question, which meant we really did a lot of stuff yesterday. What did we do first on a problem like this when we're trying to find out where this factored equation is equal or less than or equal to 0? Find out where it's equal, or if there wasn't an equal sign, find out where it's not equal. But this is equal, so these will be critical numbers with colored in points. And that is at what?
0.
0, 3, -1, 4. So I'm going to mark -1, 0, 3, 4. And then all I got to do is check everywhere, right? Now I did give you a little hint yesterday. I said that it should alternate shading in between there, unless what? Unless it was a even power. And if it's an even power, what happens on either side? It's the same one. If it's not shaded, it's not shaded. If it's shaded, it's shaded. So let's just check this first one on this side. I'm going to check, say, -2. Checking -2. And if I plug a -2 in the first factor, I get a -2 cubed times a negative, which is plus. A -2 minus 3 squared is still plus. A -2 plus 1 is -1 to the 5th negative. And a 4 minus a -2 is plus. So all of that together means what's happening here? Negative? And do I want to shade negatives on this particular problem?
Yes.
I want this to be smaller than 0. So yes, I do want negatives. I'm going to shade that. And guys, if you want to forget that rule that I was giving you before, then you just have a lot more to check, don't you? But what did it take me? 20 seconds to check? So maybe you're at another minute and a half tops. But if you want to use my rules for alternating and not alternating, -1 came from what? An odd power group. An odd power group, what happens on either side? It should be the opposite. So if it's shaded here, it's not shaded there. Where did 0 come from? 0 came from an odd power group. So it should also alternate, right? So if it was not shaded here, shaded here. 3 came from a what? Even power group. So if it's shaded on the left side of 3, it's going to be shaded on the right side of 3. And 4 came from an odd power group. So if it's shaded on one side, it should be not shaded on the other. That's a lot easier than checking, I think. But just to make sure we did this correctly, if I check 5, which it's not bad to go ahead and just check another value, see if you made the right mentality all the way across. 5 in here would give me a negative, a positive square, which is positive, a positive to the 5th, which is positive, and a negative. And 2 negatives and 2 positives gives me a plus. Do I want to shade this where it's positive? No. So everything kind of checked out, and I feel a little bit better about my analysis. So what do I write down as my solution here?
X is less than or equal to -1.
You could say that, or negative infinity to -1 with a bracket on the -1. And then? Or
X, or 0 is less than or equal to X, which is less than or equal to 4.
Great. Or you could say bracket 0, comma 4 bracket. So I really like interval notation, but AP Cal takes both. Math tournaments tend to lean probably towards the interval notation more. I may or may not ask you to put it a certain way, but if I don't mention it, you pick whatever you like. Now, real question here: what would happen if this was? What would happen if I reversed the sign here? If I reverse the sign, what would be shaded?
It would just fill in the opposites.
Just this?
It would be between the 1 and the -1 and the 0.
And this, but you'd still have that point, wouldn't you? All right, so you'd still have all the 4 points, but you'd be shading in the opposite areas. Are you with me? So hypothetically, what would that look like? If this was your situation, how would you write that answer?
So,
Bracket -1, 0,
comma 0,
union with
4, comma
3.
infinity.
You got that point there, right? And you don't need an interval for a point. 3. Union with?
Bracket 4, comma.
Right? I see people every year write, how do I do that 3? And they do this. The bracket from 3 to 3. And you can do that. That makes sense, right? You can start at 3, finish at 3, everything in between those 3's, inclusive. Just write the number 3 down, right? That's what you would do if you were solving. If you were solving, you'd say -1, 0, 3, and 4, right? You just write them down with commas. Well, that's what you're doing here. You're writing down, but if there's an interval, you're just showing the interval. If it's not an interval, you're just listing the point, or the x value. Fourth ends at 11:35. Oh, we're back on page 7. So regular time. How about, do y'all remember that problem number 9?
Yeah.
Check the key on it. But I'm trying to do as much as I can in 10 minutes. How about number 11? Y'all remember the trick on number 11? There's a short way or a long way. It is a power of 2, right? 2, 4, 8, 16. If it's 2, 4, 8, 16, 32, 64, all the way up to whatever, there's a shortcut to it that keeps you from having to make a massive factor tree. The factor tree is this. Okay, difference of squares. x4, y4, x4, y4, plus minus. And then you go, well, I'm done with the prime one, but I can go further with this one. x2, x2, y2, y2, plus minus. Well, now I'm done with that one. I can do this one, plus minus. But in the end, what does it look like I've done?
Just count it out.
Not that I put the ones there. But doesn't it look like if I start with a power, it's not a multiple of 2, but a power of 2, that I went, well, what's the next highest power? 4, then 2, then 2, technically 1 is because it's like 2 to the 0, and then with an x minus y tacked on the end. Well, with that in mind, rather than do a giant factor tree with this thing, starting with x plus 32, x to the 32nd plus y to the 32nd, x to the 32nd minus y to the 32nd, and then breaking it, breaking it. What can I start with? So I'm going to go 32 with plus 16 with pluses, 8 with pluses, 4s with pluses, squares with pluses, x is 1, y to the 1 with plus, and then tack on an x minus y in the end. And it's so much easier to run through these. And I've seen these at a math tournament. We'll go throw out x to the 4096, which is, I've seen it higher than that. And it really just becomes a race who can write it down the quickest. All right, starting to get a little bit more ugly. Look down at number 12. Now, I tell my kids, my students every year, when you see a problem like this, by the time you get done with this class, you ought to almost be able to smell what kind of problem this is. Okay, not literally, but. Anybody see anything that jumps out at you here? Other than the fact that there are weird x's in weird places. Give me some. 6. The 6 to a power. Now that doesn't have a 6 to a variable power, but that does. And what is 36 really?
6 squared.
6 squared. And notice there's minus and pluses here. So this is a little bit different than that first problem we did where there was just multiplication and they all had the same power. And you were rewriting them with the same power, but it was multiplication. Here, you've got powers, but you're adding and subtracting. So you need to just smell this as a factoring problem. And after a while, you will start to get to that point. What if I rewrote 36 as 6 squared to the x? Isn't 6 isn't 6 to the second to the x the same thing as 6 to the 2x? And isn't 6 to the 2x the same as 6 to the x squared? So couldn't I rewrite 6 to the second to the x as 6 to the x to the second? And at this point, you ought to see it.
Wouldn't it be 6 to the 2 to the x?
That's what it is when I break it down. But these three things are the same. Like if I change the 36 to 6 squared, I have this. If I did power to power and multiplied, I'd have this. But this also power to power would give me that, which means they're all three related. Which means I could change a 6 to the second to the x to a 6 to the x to the second, because they both end up giving me 6 to the 2x. And then just like I did earlier, does that make sense?
Yeah.
And then just like I did earlier, when I talk about substitutions, it looks ugly right now, but what if, just for the time being, I went, you know what, just to make this look better, what if I let 6 to the x equal a? I would have a squared minus 7a plus 6. And isn't that a little easy to factor? You can see here that that factors into a, 6 and 1, both negative. And then now I can just plug the a back in. And do I go any further with this? Do I try to solve? Tell me why or why not? No, because it said factor. And there's not even an equation. So it's not like I can set it equal to 0 anyway, because it's not set up that way. 13. It's an uglier look. When you look at 13, you smell it, you gotta be like, oh, it's a vacuum problem. Smell it from here. Now what do you kind of see? Do you see some kind of common thread in there? They've done a little bit of extra to mess with you here. Like here, you said you saw six bases of 6. What do you see here? Bases of 2 with a power of x. This power of 5 is just messing with you. That 2 right there is messing with you. Let's see if we can rewrite all this as a base of 2 to the x, and then make a substitution. Now, first thing you have to remember is this. Do you remember this rule? Right there? Like bases add exponents? Does it only work going this way? Or if I gave you something to a power plus a power, can I rewrite it this way? Seems like it should go both ways, right? So how can I rewrite 2 to the x plus 2? 2 to the x plus times 2 squared. See, like bases add exponents. That would be right? Okay, let's bring down the 3. Let's bring down the 2 to the 5th is just a total distractor. That's really just 32. And then what is 2 to the 2x? How could I rewrite 2 to the 2x based on what I learned over here? 2 to the x.
2 to the x times 2 to the x. 2 to the x squared.
2 to the x squared. Are you with me? So that could be 2 to the x quantity squared. And at this point, could you make a substitution there and there? I call it a. So again, let 2 to the x equal a, and I get a squared plus 32 plus 3 times 4 is 12a equals 0. Can you solve that? It's in the wrong order, but can you solve it? Let's try it. A squared plus 12a plus 32. So what? 8, 4 plus plug the 2 to the x back in. Actually, keep solving. A equals negative 8. A equals negative 4. Plug the 2 to the x back in. Now here's where I threw a little curveball at you. If it was positive 8, what would your answer be? 2 to the what gives me 8? 3 if it was positive 8. Positive 4, 2 to the what gives me 4? Not so bad. Now, what power can I raise unto to give me a negative number?
You can't.
I can't. Think about it. If I raise it to a positive number, like 2 or 3 or 4, I get positive answers, right? And if I raise it to a 0, I get 1. And if I raise it to a negative number, all that does is what? Flip it.
Yeah.
So is there any way to get a negative out of this?
No.
So if I ever see something like that where an exponential function equals a negative, that doesn't make sense. But if it was equal to a positive number, I should be able to do it. Like 2 to the x equals 8, I should be able to say x is 3. Y'all seeing these? Very last question's a little tricky. And I have 2 minutes. Awesome. Dadgummit. I may attach a video on this for today, like a little small 5-minute video on doing these 2 problems. Make sure you watch it, okay? But real quickly, what would you do to solve this when the bell rings? Just go. What would you do?
Find where it's equal.
So most people probably cross multiply to solve, right? Isn't that what most people do when you see a fraction? Now cross multiplying, do you know that that's the same thing as multiplying both sides by this, x plus 2? Now I have a question. This left side is going to be x squared plus 2x. This right side is going to cancel, and I'm going to get a 3. What do I bring down? Now some people would say, oh, we'll just bring down the greater than or equal to 2. But I thought if we multiplied both sides by a negative, we reverse the sign of the inequality. And if we multiply both sides by a positive, we don't change the sign. Isn't that right? Well, what did I just multiply by? Is that positive or is that negative? It's both. Sometimes it's going to be positive if x is bigger than negative 2. Sometimes it's going to be negative, right? So what do I do here? I don't have any idea what the inequality is. But I do still know that it's either equal or not equal. So if it's equal, I bring down an equal sign, I solve, and at least I can find the places where it's equal, right? Now if it's a not equal sign, I'm finding where it's not equal. These would be open circles. But this right here tells me equal, equal. Now here's what gets a little tricky. Can x be negative 2 in this problem? That's undefined there. We haven't run into that yet. Here, x can't be 1. If x can't be negative 2, open circle it there. And then guess what you're going to do in between these? Check, 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 check for the inequality part. And all rules about alternating are off. You're just going to have to check them all. I'll do a video on these 2 and walk through a little more slowly if you want to go back and look at it. And it probably won't be any longer than 8 minutes or so. We just couldn't get to it in this short period. Y'all have a good one. Let me know if you have questions for this test.